Hello students, I hope you all are fine. Students, as you know that we have started unit 4 chemical bonding of class +1. So students, here we have discussed about the chemical bond, what do you mean by the chemical bond and types of bond. So we have discussed about the ionic bond, about covalent bond, and today we will study about the coordinate bond. What do you mean by coordinate bond, students? Coordinate bond is that bond which is formed by one-sided sharing. Here students, one-sided sharing will take place. One-sided sharing means here one element will be donor, one will be donor element, and second one will be the acceptor here. Second one will be acceptor. You can understand this concept with help of an example, students. If I talk about group number 13, molecules of group number 13 elements, like if I have BF3. Okay, so students, here you know very well, if I talk about boron, its atomic number is 5 and configuration is 3, means there are 3 valence electrons, okay students. So it can form maximum 3 bonds, and students, here you can see this boron, it is sharing one electron with this fluorine, and one with this one. Okay, so students, after sharing, also it has only two electrons, two here, because one bond contain two electrons, and two here. So student, after bonding also, it has only 6 electrons. After sharing also, it has only 6 electrons. But you know very well, according to the octet rule, there should be 8 electrons in outermost shell. Okay. If there is not, then students, either element will lose the electron, or it will gain the electron, or it will share the electron. But after sharing also, it has only 6 electrons. Means its octet is not completed till now. Then students, if I have one more example of ammonia, here central atom with students nitrogen. You know very well, what is the atomic number of nitrogen? Atomic number of nitrogen is 7. And students, its configuration will be 2, 5. Okay. Then students, here valence electrons are 5. Means it can form maximum 5 bonds. But students, here you can see NH3, means hydrogen has 1 electron in outermost shell. Okay, and nitrogen has 5 electrons. 1, 2, 3, 4, 5. It has 5 electrons in its outermost shell. So here one hydrogen has 1 electron. Then students, you can see it is forming by mutual sharing of 1 electron with this hydrogen, it is forming 1 bond, and 1 bond by doing mutual sharing of 1 electron with this hydrogen, and it is forming 1 bond with this one. Then students, it is forming only 3 bonds, but one lone pair is here. Lone pair is pair of non-bonded electron. This is lone pair. What do you mean by the lone pair? Pair of non-bonded electron. So student, here what may be happen? Here, in case of BF3, its octet is not complete after forming bond also, and this ammonia, its octet is complete, students. Its octet is complete because here 2, 4, 6 and 8. 8 electrons are there. But students, it has 2 electrons non-bonded. It has 2 non-bonded electrons. So students, it cannot completely lose these electrons, because if it will lose completely, then its octet will be incomplete. So students, it can give 2BF3, this pair of electron, only at the temporary basis. At temporary basis it can give. So students, here this, by this electron pair, it is forming this nitrogen is giving electron to this boron, means it is forming bond with boron. Here it is forming bond with this boron. Students, here it is not giving these pair for permanent basis. ओके कि भाई मुझे अगर इसको फिर से रिक्वायरमेंट होगी, इट कैन टेक फर्दर, इट कैन टेक अगेन दीज इलेक्ट्रॉन्स. ओके, एट टेम्परेरी बेसिस इट इज हेल्पिंग इट. Clear or not? At temporary basis it is helping us, helping it. In case of ionic bond, you have already seen that in case of ionic bond, students, here this sodium is giving the electron to chlorine. At permanent basis it is giving. Okay, so it is the complete transfer of electron. But here in case of the covalent bond, it is giving electron. This nitrogen is forming bond with boron. Okay, but student, it is just sharing, and here sharing is done by with this nitrogen only. So here one sided sharing is not taking place. In case of covalent bond, in case of covalent bond, you can see both sided sharing, means mutual sharing was taking place. This one is sharing 3 electron, so this one also sharing 3 electron, means same number, equal number of electrons they are sharing. But here only one element is going to be shared, only one, only this nitrogen is giving electron to this one. Okay, but it is not giving electron to this boron at permanent basis, it is just helping it. Okay students, so this one is known as the one-sided sharing. This is known as the one-sided sharing. So here student, one element is the donor. So here this one, this nitrogen is donating the electron, because it is donating, so a positive charge will attain on this one, and this boron, it is gaining, so negative charge will attain on this one. Okay students, so here this one is the donor, and this boron is the acceptor. This boron is the acceptor. So students, we have discussed about the ionic bond. In ionic bond, what was happening? Complete transfer of electron take place in case of ionic bond. But student, if I talk about the covalent bond, mutual sharing take place. You will keep in your mind these simple points. Okay, these are the some common points. Covalent bond, here mutual sharing take place. But student, in case of coordinate bond, one-sided sharing. One-sided sharing will take place. Here one element will be donor and second one will be acceptor. Second one will be the acceptor. I hope this simple concept is clear to you students. Okay, so here this nitrogen is donating and boron is accepting. In most probably cases students, group number 15 elements, group number 15 elements they behave like donor element. In almost cases it happen. They behave like donors. And group number 13 elements means boron family, and group number 15 elements are known as the nitrogen family. Okay, so here these behave like acceptor in case of coordinate bond. I hope these type of bonds are clear to you. One more type is here, that is hydrogen bond. So now we will discuss about the hydrogen bond students. Hydrogen bonds. Here bond formation take place between hydrogen. Bond formation take place between hydrogen and more electronegative element. And more electronegative element. Students, here hydrogen must be present because here bond will be between hydrogen and more electronegative element. Like student, if I talk about water, if I talk about HCl, HBr, okay, HBr, then here you can see one oxygen and two hydrogens are there. Two hydrogens are there. Then students, here this one bond oxygen is more electronegative element, okay, and hydrogen H less. So student, here bond between hydrogen and oxygen. So they can form hydrogen bond. They can form hydrogen bond. Here students, if I talk about the hydrogen bond, there are two types of the hydrogen bonding. One is the intermolecular hydrogen bonding and intramolecular hydrogen bonding. Intermolecular hydrogen bonding and intramolecular hydrogen bonding. Intermolecular and intramolecular. What do you mean by the intermolecular hydrogen bonding? Students, if hydrogen bonding take place between two different molecules, okay, that hydrogen bonding is known as the intermolecular hydrogen bonding. Like students, if I have one water molecule here, this one, OH, you know very well, two lone pairs are there. This one is second. Okay. Then next one. Then you can say students, here, this one is the one molecule of water. This one is second molecule of water. And this one is the third molecule of water. Okay. Then student, here, hydrogen and oxygen is more electronegative. So this most electronegative element and hydrogen, they can show an interaction between them. Okay, they can show an interaction between them. They can form a bond because bond between hydrogen and bond between electronegative element, that is known as the hydrogen bond. So students, they form hydrogen bonding. They form hydrogen bonding. Okay, and here this oxygen and this hydrogen, they can also form hydrogen bond. So students, here you can see different molecules are forming hydrogen bonding between them. So that type of hydrogen bonding is known as the intermolecular hydrogen bonding. That type of hydrogen bonding is known as the intermolecular hydrogen bonding. So I hope this point is clear to you. Then student, if I talk about the intramolecular hydrogen bonding, Intramolecular hydrogen bonding is that if hydrogen bonding take place in same molecule, in same compound, if it take place, like students, you can take example. If I talk about 2-nitrophenol, this is phenol at 2 position. We can attach nitro group also. So this one is the 2-nitrophenol students. Okay. Here what will happen? I can write this in this way. O and H. Bond between O and H here. And student, I can write nitro group in open way and this way. Okay. So you can see here electronegative element oxygen is present as well as hydrogen is present in same compound. Okay. So student, they can show interaction between them. They can show interaction between them. Okay. Then they can form bond between them, and that is known as the hydrogen bond. So here you can see hydrogen bonding is taking place in the same molecule, in same compound. So this type of hydrogen bonding is known as the intramolecular. That is known as the intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Okay. So students, if hydrogen bonding take place into different molecules, in different substances, in different compounds, then it is known as the intermolecular hydrogen bonding. But if hydrogen bonding take place in same compound, then it is known as the intramolecular hydrogen bonding. Student, you know, if hydrogen bonding take place, then solubility also increases. You know very well, ethanol, alcohol can be dissolved in water at any extent. Why it is? Students, if I talk about alcohol is ROH. R group is the alkyl group here. It may be methyl, ethyl, propyl, okay, whatever. Then students, OH. OH group is the alcoholic group here. So, if I talk about alcohol, this one is structure and water. Then you can see alcohol and water also can form hydrogen bonding between them. And due to formation of hydrogen bond, they are soluble. Alcohol soluble in water. Okay, students. So these are some common types of the bonds. Now, students, we will discuss about the Lewis structures. Electron dot structure. How can we draw? Students, if I talk about the Lewis structures, like if I have H2 and I say make Lewis structure for that, Lewis dot structure you can prepare. How can you make, student? First of all, you will write configuration for that element. Here we are having hydrogen. You know very well, hydrogen has atomic number 1. So its configuration will be also 1. Okay, and student, here valence electron is also 1. Then students, you will write valence electron, number of valence electron with the element. Okay, so there are 2 hydrogen atoms. So second one also Then student, you will show the mutual sharing. Then you will show the mutual sharing. Here by doing mutual sharing of one electron, okay, they can form covalent bond between them. So in this way you can draw the Lewis dot structure. You can take one more example. If I talk about the CO2, if I talk about CO2, how can you draw the structure for that? So here you are having carbon atomic number 6, so its configuration 2,4. Then you are having oxygen, two oxygens are there, atomic number 8, and configuration is 2,6. Configuration is 2,6. Then student, you will write valence electrons. Keep in mind that you will write the valence electron only. Valence electrons means electrons present in outermost cell, okay, in valence cell. Then students, you will identify the central atom. Here central atom is carbon. Here central atom is carbon. You will write valence electron of it. So it has 4 valence electron, 1, 2, 1, 2. Okay. Then you will write students surrounding element you will write. So here surrounded elements are oxygen. How many oxygens are here? 2 oxygens. Then you will write there are 2 oxygens. There are 2 oxygens. Then students, you will make all valence electron. So here valence electrons are 6. One oxygen has 6 valence electrons. Okay. Then student, you will see about sharing. Means by sharing how many electrons they can complete their octet. So here carbon has 4 electron in valence shell, means it needs 4 more electron for getting stability, for completing its octet. And here one oxygen has 6 valence electrons, means it needs 2 more electron. So student, they can share with each other. If it will share 2 electron with this one, okay, and 2 electron with this one. Then students, you can see here this oxygen has 6 plus 2, 8 electrons now it is stable. This one oxygen also 6 plus 2, 8. So it is also stable. And this carbon 2, 4, 6, 8. So this one is also stable. So student, in this way you can draw the Lewis structure. First of all, you will identify the central element. Then you will write the electronic configuration. Okay, after writing configuration, you will see the valence electron. Then you will make all valence electron with all elements present in a molecule. Okay, student, then you will see how many electrons are needed for getting stability. How many electrons are needed for getting stability? According to that, you will do the mutual sharing. Okay, students. So I hope this concept is also clear to you. Okay, how can we draw the Lewis dot structure? Then students, tomorrow we will discuss about the formal charge, some terms related to the bond, chemical bond, like bond order, like bond length, bond strength, bond energy also. So I hope this concept is clear to you. So thank you. Have a nice day.